Hello, this video is going to look at exponential graphs. It is particularly going to look at two ideas, which are how to plot an exponential graph and also how to solve some of the more challenging GCSE problems about finding the equation for an exponential graph. So here we have an example of an equation which would create what's called an exponential graph. The equation is different to most others because the unknown that's on the right, the x, is now in the position of being a power, which in most other kinds of graph it has not been before. So when plotting this graph, we'd go through a very similar process to how we may have done other graphs, where we'd get a table of results and we'd work out some values. Now, when I complete these tables of results, I'll often work from right to left so that I'm working with the positive values of x, which is usually a bit easier. So from the right, where we've got 1, 2, and 3, if I substitute those where x is, I would get 2, 4, and 8. And so we can see that as we're going from left to right, these values have been doubling, which we would expect with powers of 2. So as we go left, we should remember that anything to the power of 0 is 1. So this point is going to be fairly easy to remember. And then all the other values will be fractions. They're going to be halves, quarters, eighths, and gradually tending towards 0. Now, a common misconception is that negative powers will create negative values, but if you use the pattern in the table, you'd realize that it's not going to work out like that. So what I'm going to do next is I'm going to show how this graph would look when it's plotted. So here we're going to plot the graph of y equals 2 to the power of x. You'll notice that the y-axis is scaled differently to the x-axis. This is because the values of y will get much larger, and so you'll need to make sure that your axis is scaled carefully. In some questions you're given the axes, in others you have to draw them, so do bear that in mind. When you plot the points, you'll get a curve like this, which is how most exponential curves are going to look. Now, this has just gone through how the plotting of the graph works. Now we're going to look at how to determine the equation of an exponential curve from an exam question. This here is an example of an exponential curve question that could appear in an exam. We have an exponential curve and we're asked to find its equation having been given a few points, and in one of those points we actually want to determine the y coordinate value where it says k. So to start off with, we're going to have to substitute these coordinates into our equation that we're given at the top, and the first point to start off with is the one furthest to the left here where we've got it on the intercept. Now if we start where x is 0 and we substitute that into the equation, we're going to eventually get to the point where p equals 8. The reason for this is that q to the power of 0 is going to be 1, so on the right hand side you'll just be left with p. On the left, the y coordinate was 8 when x was 0, and so now we've determined that p equals 8. The next step is then to put that into the equation and then substitute the values of 1 and 18 into it to determine the value of q. So we know that y equals 8q to the power of x. So now we know that 18 is going to equal 8q to the power of 1. As q to the power of 1 is just q, then that means with a little bit of division we can get our value of q. Now, not entirely sure what the best way to write q would be, whether to write it as a mixed number, an improper fraction, but I've gone with decimal here. It doesn't make a great deal of difference to the problem, and it wouldn't make a great deal of difference when you're answering it. So you just have to work with what's comfortable. I think if this was a non-calculator question, and it could well have been, I would have been tempted to have kept it as an improper fraction. But from here, we can now get a final equation of y equals 8 times 2.25 to the power of x. And I have put the times sign in here just so that we are very clear of what's going to happen in terms of BIDMAS, that only the q is having a power of x and the 8 is separate and multiplying it. So now I'm down to the last value k, and since I have been given the value of x of 1.5, I can just substitute that in. This would give me that y is 27, which means that's the y coordinate, and so k is 27. And then that would complete this style of question. The next question that I'm going to look at is slightly different. We don't have a coordinate for the y-intercept, and we are given two coordinates on the graph fully. We're still asked to find values of p and q, and so we still need to go through a very similar process here, but it is a little bit more complicated. So we'll start off with substituting in the values of 1 and 5 from the first coordinate into the equation. And what that's going to do is basically tell us that P times Q has to equal 5. Now, we won't start guessing what P and Q are here because that won't overly help, and there's no guarantee that either P or Q are going to be whole numbers. So we couldn't really do a process like factorizing here and start saying, well, maybe it's 1 and 5 and work with it. But we do need to keep a hold of that fact because it will be helpful when we substitute in the next coordinate. So substituting in the next coordinate will give us that 320 equals PQ to the power of 4. Now, on the face of it, this might not look very helpful, but because we know that P times Q is 5, I can split PQ to the power of 4 so that it is a PQ times Q cubed. And so what I'll be able to do here is replace that PQ on the right with 5, because from the first stage of this working, I figured that PQ did equal 5. And now I'm at a point where I will be able to figure out Q because the unknown P has been eliminated from this problem. So divided by 5 gives me that Q cubed is 64, so Q will have to be 4. Now I know that Q is 4, I can go back to that first value I substituted in and figure out what P is. And so this will give me that P is 1.25, and I've now answered the problem which asked me for those two values. Now these are two types of exponential curve questions that you could get, or exponential graphs. It might not cover every type of problem that could be written, but the general idea has been to substitute the values in and to start figuring out from there what you're left with and how you could determine the missing values. So in an exam situation, you may have multiple marks for this question, and a pretty good start point is to begin by substituting the values in. If it's a plotting an exponential curve or graph question, then follow the ideas that were mentioned earlier. If you can, select your values of x if they're not already given, and start figuring out some of the key points of the graph, and remembering it should follow the curve shape that you've seen in the questions so far. Hopefully this video will help you in being able to answer future questions on exponential graphs. Thank you.